What would happen if we detonated a powerful nuclear weapon on the Moon? Would the explosion knock its orbit towards Earth, causing tidal waves and misery? Or could the Moon be destroyed, showering the Earth in a rain of meteoric death? Subscribe and like for space updates. Well, is a 5-megaton thermonuclear warhead about twice as powerful as the most powerful bomb ever detonated? We'll also place a number of curious astronauts around the Moon as observers. Let's push the button and slow down time. For the first few milliseconds, nothing much happens outside our weapon. Meanwhile, inside, high explosives send a shockwave to a radioactive metal core, compressing it so much that it reaches criticality and starts a nuclear fire. This is an efficient chain reaction. The 100 million degree plasma created in this first stage sets off the second stage, with atomic nuclei fusing like they do in the core of a star. Very briefly, our weapon contains one of the hottest places in the universe. And only now, barely 10 milliseconds later, does the rest of the universe find out that anything has happened, as suddenly the bomb dissolves and a flaming star of nuclear death is born. So far so good. But everything that happens now is very different from what we're used to on Earth because of one major difference. There's no atmosphere. As the fireball shines, it releases a flash of X-rays and thermal photons, a wave of silent heat which rushes outwards in all directions. On Earth, this heat would char and burn everything within a 50-kilometer radius at least. But on the Moon, without an atmosphere and oxygen-rich air, there's no burning at all. Also, there are no things to burn. The crunchy topsoil of the Moon is made from silicate rock and metals chewed to dust by eons of meteorite impacts mixed with tiny traces of water. When heated by the explosion, X-rays from the fireball vaporize a thin cloud of rock from the lunar surface, while the unlucky dust that's inside the fireball melts into glass. Any astronauts watching the show within about 50 kilometers can expect to be fried. And now we begin to see one of the biggest differences between explosions in space on Earth. The atmosphere fights back against the plasma bubble. Its expansion is violently stopped within moments by the pressure of the atmosphere. But this is not good news. As the fireball rams the atmosphere, it produces the most destructive part of a nuclear explosion on Earth. Compressed air around the explosion rushes out faster than the speed of sound, shattering buildings and roaring so loud it ruptures organs. But on the Moon, there is no shockwave. It means nothing to impede the expanding explosion in space. On the Moon, the fireball just grows in eerie silence as there's no atmosphere to stop it or to give it a voice. This would be an amazing thing to watch from a safe distance. Unfortunately, there's hardly any safe viewing distance for a nuclear explosion on the Moon. Without an atmosphere weakening the deadly ionizing radiation that can scramble DNA, anyone close enough to get a good look will be exposed to fatal amounts of radiation. But of course, that's not all. While all of this happens, the explosion hammers against the Moon, transferring about a tenth of the explosion energy into seismic waves, powering an intense moonquake. The Moon is much smaller than the Earth, and our astronauts will feel an inescapable violent shaking no matter where they are standing. Comparable to an earthquake of 7 on the Richter scale, this shaking could seriously damage or even level infrastructure we might have built anywhere on the Moon. Those who hid on the far side of the Moon would have no idea it was an explosion. The quaking would feel like an asteroid the size of the Great Pyramid had struck. And it's not over yet. Where our bomb explodes, the ground splatters like water when a rock strikes a pond. As the explosion pushes against the surface, it may excavate as much as 100 million cubic meters of dust and rock, forming a crater 8 kilometers across, while bedrock is pulverized to rubble. Debris is shot into the sky. In every direction. Again, without an atmosphere, there's no drag to slow any of it down. Much of the debris scattered never returns to the Moon, flying off faster than escape velocity. A flurry of micrometeorites have been cast off to explore the solar system, many of which will rain down on the Earth, though few will be larger than pebbles. Any satellite, astronaut, or space station in the way, though, will have a really bad time. Micrometeorites are launched at many speeds and angles, allowing them to spread all over the surface of the Moon. Like bullets, they'll punch through our curious astronauts, no matter where they stand. Finally, our explosion comes to an end. On Earth, the fireball rises like a hot air balloon, forming a sort of stalk. As it reaches up, cooler air is drawn in around it, rounding the top into a mushroom cloud. But on the Moon, well, you know by now, no atmosphere, no mushroom. The larger the plasma gets, the cooler it becomes, and the less energy it has to make interesting or terrifying things happen. Within seconds of pulling the trigger, the bubble reddens and fades from view. It would be visible from the Earth, like a star flickering to life, only to fade out right away. A spark, and then nothing. As the cloud of tiny debris reaches far above the surface of the Moon, it's illuminated by the sun for a few minutes, giving it an eerie. For anyone left to observe the spectacle. Beauty.